Hey guys, Mr. Backberg here. In this video we're going to be looking at population models. Now one way exponential and logistic functions get used a lot is with modeling populations. So we're going to take a look at an example where we model the population in Austin, Texas. So we've got some information presented to us. In the year 2010, Austin had a population of 815,974. But in 2015, that population increased to 931,830. And we're going to take a look at this and we're going to think about this as an exponential function, and we're going to try to figure out when this population would reach 1 million. So we're going to be dealing with an exponential function modeling this population based on time. So I'm going to call my function p of t. And in our function, what we're going to have is a p sub 0 value, which is going to stand for the initial population when we start tracking our data. Then we're going to multiply that by some base value raised to the power of t, since we're talking about our time. Now, we know our initial population when we started tracking our data. That was the 815,974. So I can fill that in for my p sub 0 value. But now, I don't know what my b value is, but I do actually have a way of figuring out what my b value is using that second set of data that we were given. So what I'm actually going to do is, where this p of t is, I'm going to fill in that second population, that 931,830. This is going to equal our initial population, which is the 815,974. We don't know our b value, but we do know that this new population happened after 5 years have elapsed, so my t value is 5. Now what I can do is I can divide this 815,974 over to the other side, so I would get 931,830 over the 815,974 equaling b to the 5th power. But then if I wanted to get b alone, I would have to take the 5th root of each side. And when I do that, I'm going to get a b value of about 1.0269. So I can fill that in as my b value within this population function. Now I want to figure out when my population is going to reach 1 million. And I'm going to use my calculator to help me out. So in my calculator, I have two equations typed in. I have that population model that we just came up with, and in my second equation, I have a million, since we're trying to figure out when this population is going to reach 1 million. Now, I will have to adjust my window. We want to figure out where our population is 1 million, and that second equation that we typed in said y was going to equal 1 million. So I need my y maximum value to go above 1 million so that I can see where the intersection point is happening. So I'm going to make my y maximum 1,500,000. And then when I hit graph, we'll get a picture that looks something like this. Now we're looking for where these two lines are going to intersect each other. So I'm going to go second trace and pick intersect. Now I've only got two graphs plotted out, so I can hit enter 3 times, and it'll tell me that my graphs intersect at an x value of 7.66. So we ended up with an x value of about 7.66. Now thinking about this in terms of time, that means 7.66 years after we started tracking the data, which happened in 2010. So that would put us towards the end of 2017, maybe even into the beginning of 2018, when our population reached 1 million. Now, over a short period of time, like we just looked at in the last example, exponential modeling can work out really well because populations can grow very quickly over a short period of time. But if we look over a longer span of time, populations won't continue to increase exponentially forever. There's a limit as to how big a population can actually get. So a lot of times, as we look at a longer period, a logistic model works out better. So say we wanted to model San Diego's population going all the way back to 1900. Then we can actually represent this using a logistic function. So I can use this logistic model to represent San Diego's population. And in my logistic model, t is going to represent the years after 1900. Now, I want to figure out when my population reached 1 million. and I'm going to use my calculator to help me out. So I've got my logistic model typed in, and I've also got 1 million typed in as my second equation because I'm going to be looking for the intersection point. I will need to adjust my window. I've got my X max going out to 100, and I've got my Y max going out to 1,500,000. When I hit graph, I'll get a picture that looks something like this. Now I want to figure out where my lines are intersecting, so I'm going to go second, trace, and pick option number 5, intersect. I'll hit enter 3 times, and it'll give me an X value of 85.27. Now we said that our X values, or our T values, were going to represent the years after 1900, so we would be able to approximate that San Diego's population reached 1 million people in about 1985. That's going to be it for this video. Thanks for watching.